Solving equations by completing a square. Example number 1 for problem 1 on today's homework. A squared plus 2a minus 3 equals 0. The first step is to group the a squared and a term together. Add space and continue the rest of the problem, and then add space on the other side of the equation. Reminder, here we're going to take the middle term, which is 2. We're going to divide it by 2. I'm going to adjust the lighting so maybe you can see the calculator a little better.
Yeah, you can see it now.
Alright, so we're going to take 2 divided by 2. That gives us 1, and we're going to square it. Look at the little button for square. There. It's 1. We add 1 to each side of the equation. And now we factor a squared plus 2a plus 1. Part of completing the square is to make this into a perfect square trinomial. So adding 1 made it a perfect square trinomial. It factors what two numbers multiply to 1 and add to 2. Becomes a plus 1 times a plus 1. And then we write the remainder of the problem. Here we go ahead and simplify. 0 plus 1 is 1. Remember, anything times itself is squared. So a plus 1 times a plus 1 becomes a plus 1 squared minus 3 equals 1. The next step is to solve for the variable. Our variable here is a. We start with our order of operations. We undo any addition or subtraction first. Remember, we're doing order of operations in reverse. I'm left with a plus 1 squared. Negative 3 plus 3 cancels, equals 1 plus 3, which is 4. The next step is to take the square root of each side. Remember, we're trying to get rid of the square, so the only way to get rid of the square is to take the square root. We're going to take the square root of each side. This undoes the square, leaving us with a plus 1 equals the square root of 4, which is both a positive 2 and negative 2. Now, the only thing stopping us from having a by itself is 1, so I'm going to subtract 1 on each side. That leaves me with a equals negative 1 plus 2, and a equals negative 1 minus 2. So our solution to this equation becomes a equals 1, and a equals negative 3. We can also write it as the ordered pair 1, 0, and negative 3, 0. Both are our solutions.